Hello everyone, you are welcome to today's lesson. Today's lesson is going to be on vectors. Okay, however, we will concentrate on only core math vectors. So the aspect of vectors that you will see only in core math. Okay, that is what we are going to cover. Okay, but please take note, okay, the all that we will learn here, you need to know that in elective math as well. So we'll build on this foundation when we get to okay elective math. So we'll do the exclusive elective math to when we are dealing with elective math. But today is a core math class, so we'll concentrate on everything about vectors in terms of core math. So please stick and stay with me whilst I take you through this lesson. Okay, all right. Before I start, quickly let's go through the learning objectives. Okay, so as a result of studying this topic, or by the end of this lesson, the students will be able to understand the concept associated with vectors. Okay, define a vector, represent vectors using arrow notation and component form. Okay, know the various forms of representing vectors. Okay, then know the types of vectors, distinguish between a position vector and a free vector, add and subtract vectors algebraically and graphically, multiply a vector by a scalar, and understand the effect on magnitude and direction. Find the magnitude between two vectors, find the midpoint of a line joining two vectors, determine whether or not given vectors are parallel or perpendicular. Okay, find the resultant of vectors, express points as vectors, express free vectors as position vectors, determine the length, the bearing or direction of vectors, then express magnitude bearing vectors as column vectors and vice versa. Okay, so this will be the learning objective for the entire lesson. Okay, however, today we'll look at what the definition, we'll look at the algebra of what of vectors, we'll look at finding the magnitude of what of vectors. Okay, so this will be our learning objectives for today's lesson. Okay, so quickly let's go to the next slide. Okay, so the definition. In mathematics, a vector is a quantity that has a magnitude and what direction. Common examples of vectors are displacement, velocity, acceleration, force, etc. Okay, so you should know that anytime we talk of a vector in mathematics, we are looking at a quantity that has both magnitude and direction. Okay, so you know any quantity that has only magnitude but no direction, we know that is a scalar. You know, you do that in IS, okay, or even in JHS, okay, science. Usually you are asked to distinguish between a vector quantity and a scalar quantity. And the major distinction is that a vector quantity will have, apart from it having a magnitude, it will also have a direction, and that's what a scalar quantity lacks, the direction. So anytime I tell my student, anytime you are told, okay, by someone that you are a vector quantity, you should be very happy. It's a compliment. See that to be a compliment. Okay, it means you have direction. Indirectly, you have direction. So it means you are focused, sort of. You know what you are doing. The future is bright, sort of. However, okay, if you are told that you are a scalar, that cannot be a compliment. I don't want to say that that is an insult, but you can take it as such. Okay, because if you are told that you lack direction, obviously you will not be happy. Okay, so this is just by the way. Okay, so now I continue to read. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. So if you look at the picture here, okay, exactly what you have in the picture here is what is here. So you can see there is a directed line segment and the direction is indicated by the arrow. So the arrow is telling you which direction. Okay, and obviously you can see that you are moving in this direction from the point A to the point B. So that is the direction. And from A to B will be the magnitude, what is referred to also as the length of the vector. Okay, then we'll talk much about the magnitude, okay, pretty soon. Okay, then graphically, a vector represents an arrow connecting an initial point A with a terminal point B and denoted by AB. So your 2 points, then you indicate a line on top, but not just any line, a directed line. You know there is the arrow that is giving it a direction. So without the arrow, it becomes only the what do you call it, a line, but not directed. So indirectly, a vector is what? Is an array, because you can see that the line that you have here is an array. Take note. So those of you who uh, were under my voice when I was teaching, what do you call it? I think, yes, plane geometry 1. Okay, we looked at the various types of lines that we can encounter. Okay, that was just by the way. So we are done, okay, with what we have here. So it means you take note, anytime you are writing a vector, let me pick my pen and write something here. So if I have AB, okay, if I don't put any line on top, okay, it's still regarded as a line AB. If I do this, it is still a line AB, which is still a scalar. Okay, immediately I attach that arrow, then it moves from a scalar to what? A vector. And it becomes what? A vector AB. So this is read the vector AB. Okay, so if you are using point to indicate vectors, this is how you do. You indicate your 2 points, okay, and your 2 point, the first point, which is what we call the initial point, comes first, followed by your terminal point. So just as you can see, this is starting from the point A and then ending at the point B. So you write your AB, okay, then you indicate your arrow on top. The direction of your arrow will tell you your initial point and your terminal point. So I can equally do this, though usually we give the direction this way, moving from left to right. But if you see this, okay, take note, it's also telling you that the initial point here rather is B and the terminal point is what? Is A. So take note, that was just by the way. All right, so quickly, let's go and look at what? These two special vectors. We will need them, okay, especially going forward. I will be using them often. I will be meeting them very often. So these are two special types of vectors. We'll look at the other types anyway going forward. Okay, so a free vector, you need to know what a free vector is. And a free vector is a vector starting from anywhere but the origin. So any vector that, okay, does not start from the origin is regarded as a free vector. So any vector that does not take its source from the origin, okay, is what we call a free vector. And usually, okay, geometrically, graphically, okay, we can indicate a free vector. We can draw it anyhow. So if I have a vector AB, I can draw it anyhow. My point A, my point B, I give it a direction. Somebody can also draw it this way. The point A, the point B, give it a direction. It's a free vector. You can draw it anyhow. You can draw it freely anywhere. Okay, so you can also understand from that perspective. So example, okay, the vector AB, the vector AC, the vector PQ. Obviously, if you look at these three vectors, okay, the initial point of the first vector is A. The second one is also A. The third one is P. Okay, and the last time I checked, in terms of what, in maths, the origin is usually represented by what? O, unless otherwise stated. So we use O to represent the origin. So because your initial or your starting point, none of them is what? O. Okay, you should know that this vector that you have here, these vectors will be free vectors. Each of them is a free vector. Take notes. Once you know the definition of a free vector, automatically that of a position vector is known, its opposite. So if a free vector is a vector that does not take its source, that does not start from the origin, then obviously you know the position vector will be a vector, okay, that starts from what? The origin O. Okay, so every free vector, okay, the starting point will not be O. Every position vector, you always start from O and end at another what letter. You know that usually points are indicated by capital letters. So you always connect 2 points. Okay, however, your first point, if it is O, okay, the origin, then you should know that the vector that you are dealing with is what? A position vector. That's my point. Now we also need to know, okay, the special. So you can see that one thing in common for all position vectors, okay, will be, okay, the source, which is O. So every position vector will have the same initial point, but all three vectors will not have the same initial point. The initial point will always vary, okay, or usually can vary, but with this one cannot. It must always be what? O. Okay, so your terminal points that, okay, equally can vary. Okay, so take note. So now what do? We look at the statement, special notation for position vectors. In print, position vectors are indicated using boldface letters. So anytime you are reading a math book, a math textbook, a math pamphlet, a math literature, any book that you are reading and that is math, if you see any small letter that is in bold, okay, you should know that you are dealing with what? A vector. That is a way of representing vectors in print. Okay, and I take it again. Anytime you are reading any math literature and you see a letter that is in bold, a small letter for that matter, okay, especially if you are looking at, you are reading vectors, you should know that that letter is representing a vector. Okay, and it's a special vector, okay, which will be a position vector. So it's a special notation for a position vector or for position vector. So take note. So if I have a position, let's quickly look at the table here and I will give you another information, because when you are submitting, when you are writing, when you are giving your solution, you will write. Okay, so you are not going to print. So the way you indicate vectors, okay, in the special form, the position vectors will differ a little. So I will quickly, okay, very soon I will let you know. So if you look at this, you can see that, okay, we have position vector column and we are looking at the position vector OA, our usual position vector. A special notation that you see in print, okay, will be, you can see that this A is bold. Okay, however, when you are writing it, okay, you usually don't encourage you to bold it, okay, to indicate the vector nature. So what you do is you write the letter, small letter A, then you put the sign, a curly line just below it. Okay, that curly line, okay, as somebody will say, logology line, okay, whoa, is what we call, okay, tilde. Okay, tilde with E, not A. So tilde will be this, okay, sign. Okay, so it's just like this, just below it. So you can, okay, equally Google and find more about that. Okay, so in the same way, okay, OB. So if you look at this, okay, we said the special notation is A, small a. If you look at it, the special notation is small b. Okay, so when you are writing it, that's the special notation in print. When you are writing it to small b, then you bring your tilde, your Kelly line, your logology line. Okay, then again, if you observe very well, you can see that the letters that you have here, the small letters that you have here, okay, they are all taken from the non-common point, okay, which is your terminal point. So the terminal point that we use to indicate our special, okay, notation or represent our special notation, the small letters of the terminal point there. So here the terminal point will be what? Will be P, so small p. Okay, so when you are writing it, you write it as small p, okay, then tilde. Okay, then this one too will be small q, okay, tilde. Take note of that. Okay, and again, it's coming from, because they will all have the same initial point, the origin O. It is the terminal point that usually we use to name, okay, or represent them. Take note of that. So thank you very much. If you are following, we thank God. Let's move on. Okay, so we are now going to look at the forms of representing vectors. Okay, in actual fact, we have three main forms. Okay, the third one is for elective math, so I will speak of only two, the first two. Okay, I will treat, or we would look at what the third one, okay, strictly undilated math. Okay, so you will see only two forms here. That doesn't mean you have only two forms. Okay, so the first one is the magnitude bearing form. A vector in the magnitude bearing form, okay, so let me pick mine. A vector in the magnitude bearing form represents a quantity with both, okay, magnitude. So the magnitude will be given, which is what we know as the length, okay, and bearing, which is what we also know, or what is known as what, the direction. It is usually of the form, so here I'm using a free vector. So if I'm looking at a free vector AB, it will be equal to, and I'm going to read, you know that in math, usually we use this to represent magnitude, length. So it will be AB is the vector, so it's the magnitude of the vector, okay, comma, you can see that, then theta. Okay, so magnitude theta, you know that theta is an angle. So definitely that will be the bearing. So where, okay, this is the magnitude specified, the magnitude or length of the vector. So this is the magnitude of the vector, and theta indicate the bearing or the direction of what B from A. Okay, so please take note. So it's bearing, sorry, the magnitude, forgive me, bearing. So that's where it's taking its name from. The magnitude will be given and the bearing must also be known or is stated. Okay, so example, you can see, okay, a free vector. So this is a general example. Okay, so the first entry here, what we have here will be our magnitude entry. So that is 3 kilometers. And the second entry here is what we are going to look at as what the bearing. And usually the normal, the angle bearing, usually we state it in 3 digits. So that's why you see, okay, the actual angle is 60 degrees, but to indicate that we are dealing with bearings, okay, we precede that with what, 0, so 0, 0, okay, degrees. So this becomes the bearing. I guess my point is well made. Once again, okay, we'll look at bearing in itself, okay, as a topic in, okay, core maths, also in elective maths, okay, but we'll do it more of what course. So when we get there, I will give you more information about, okay, bearing, okay, but for now, I think my point, the basic information that you need to know here is known, okay. All right, and even going forward, you look at how to find, okay, the bearing, okay, of any vector. Okay, so before we treat bearing, okay, as a topic on its own. Okay, so quickly, let's look at the second form of representing vectors. Okay, so we have the column or component form. Okay, a vector in column or component form is usually represented in the form, and again, I'm using the free vector AB, is equal to x what y. Okay, so in the column form, okay, where x indicates the s component and y component. So this is the s component, this is the y component. Okay, so example, the vector AB, so this is a specific example, is equal to 3, what, 4. So the s component is 3, the y component is what, 4. So I think this reminds you of how you can indicate a point. You can indicate a point in this form, a column form. So I can have, okay, this point, I can have the point A, okay, to be equal to, I can state it in the row form, which will be 3, 4, or I can state the same point in the, okay, column form, which will be what, 3, 4. However, you should know the distinction. If you are talking of points, the entries here are called, okay, coordinates. However, if you are talking of vectors, your entries, okay, the name will change and it will be components. So in terms of point, this will be the x coordinates, y coordinates. Okay, but in terms of vectors, this becomes s components, y components. I guess my point is well made. Okay, now let's look at how, okay, to get, or what the upper number or the top number here represents exactly, what it tells you to do in terms of vectors, okay, and what the lower number here, the bottom number here equally, okay, tells you to do. And once you have a fair idea of points, okay, the work here is not going to be very difficult. So let's write up here. Let's read that. The top number, which is what we call the S component, okay, take notes, or the horizontal, okay, component. Okay, either the x component or the horizontal component, but usually we use the x component. Okay, is the okay, so let me take it again, forgive me. The top number is the column vector. Sorry, in the column vector, forgive me. In the column vector indicates how many spaces to the right or left to move. So anytime, so assuming I'm looking at this vector, okay, 3, 4. So let me draw my Cartesian plane, okay, because we are talking about x and y. Okay, you can see x component, y component. So this will be my y component, my s component. Okay, my x axis, y axis. That will tell me where to get. So we said, okay, if the number is positive, the direction is to the right. So if I'm looking at the number 3, 4, the top number here, because it's positive, it means if I'm starting from here, which is the origin, you know that's where we usually, okay, assuming this is where my A is, I need to move 3, okay, places, okay, to the, what do you call it, right, because my number here is positive, so I'll move 3, okay, and if the number is negative, you move to the left. So because you know this is the positive axis of the x, okay, and the negative part of, oh, sorry, forgive me, not positive, let me clear that. Okay, I meant, okay, negative. So that's the more reason why if you are indicating positive, you know, positive is to the right and negative is to the left. And that's exactly what you have here. Okay, if you are talking about the bottom number, then the bottom number has everything to do with the y. And you know that the y to the positive is up and what, and the negative is what, is down. Okay, so it means, okay, that we said the bottom number in the column vector indicates how many spaces, okay, to the top or down to move. How many spaces to the top or down to move. Remember, we said that the top number will tell us how many spaces to the left or right or left to move. However, the y will tell us, okay, that is the bottom number will tell us, okay, how many places up or down, or how many spaces up or down to move. Okay, so if the number is positive, you know, positive means you go up. Okay, the direction will even tell you. Okay, so the direction is upwards. If the number is negative, the direction is downwards. Okay, so it means if I have the vector, let's say AB, I'm still using the vector AB, okay, to be -3, negative what? 5. Okay, if I'm indicating that, if I want to draw, okay, so this is my Y, this is my X. Okay, because it is negative, my top number is negative, it means I need to move, okay, in this direction. Okay, but 3, okay, places. Okay, then what do I do? Or 3 spaces. Then the -5, negative means I need to come down. So I come down how many spaces? Okay, 5 spaces. Okay, so it means I started from here and ended here. So my vector will be this way. Okay, as simple as that. Okay, so if there are any issues when you watch the video, you can, okay, send your comments. Okay, all right. So now let's move on to, okay, the algebra of vectors. So when you talk of algebra of vectors, basically in maths, when you mention algebra, we are talking about the basic arithmetic operations, okay, how to make use of them under that particular concept, how to add, how to multiply, how to subtract, how to divide, and what have you. So here we are going to look at addition and subtraction. Then we'll look at, that is, in this case, addition and subtraction of two vectors. Okay, then we'll look at multiplication of a scalar and a vector. Multiplication of two vectors, okay, you won't get it in core math. We'll do that in elective math. So elective math students, take notes. Okay, so quickly, let me read. Okay, addition and subtraction. So we are looking at A, algebra. Okay, if the vector AB is equal to, and again, I'm using the free vector AB, is equal to x sub 1, y sub 1, and the vector CD, okay, is equal to, without the arrow, I can't read that as what? As a vector. It will be the line AB. So in that case, this becomes a point. Okay, so x coordinate, y coordinate, not the x component, y component. Take note. Okay, and okay, the vector CD is equal to x sub 2, y sub 2. The reason why, at the normal circumstance, you know, when I was teaching you coordinate geometry, I made this point. Because we are looking at, we need to get more than a vector. Okay, if I labeled my first vector the usual way, xy. Okay, and come and label my second vector CD also xy. In math, okay, this could mean that the two vectors are the same because x, x, y, y. So this to distinguish and or to indicate that they are not necessarily the same, okay, what do? We use the subs. So that's why you see the subs with the x and the what and the y. Okay, now I think I can continue. Then the vector AB plus the vector AB. So we are looking at vector addition. Okay, will be equal to what is your AB? AB is x sub 1, y sub 1, plus what is your CD? X sub 2, y sub 2 in the column form. And that will be equal to what do you do? Just as if you know how to add points, okay, you should know how to add what? Vectors. You add corresponding points, you add corresponding coordinates. But in vectors, you add corresponding components. So you add the s components, so that will give us x1 plus S2, that will give you your result, the S component of your sum. And the Y component of your sum, your result will be Y sub 1 plus Y sub 2. Okay, same for the subtraction. Okay, you subtract what? The S component and come and subtract the Y component. And that will respectively give you the S component and the Y component of what? Your result, your subtraction. So let me throw a little more light on that. Indirectly, I've said it. So to add two vectors, we add the horizontal or S component, that's the top numbers, and add the vertical or Y component, and that will also be what? The bottom numbers of the column vectors. So to subtract is basically the same thing. We subtract the horizontal or S component, the top numbers, and subtract the vertical or Y component, the bottom numbers of the column vectors. As simple as that. Okay, so now let's go and look at some word examples. Okay, so as usual, you can see our first word example. Okay, and if you read the question carefully, you will see that we are looking at addition and subtraction of what? Of vectors. So let's read this. Given that the vector AB, okay, with the component 2, negative 1. Okay, so you can see the vector BC with the component minus 3, 7. Okay, then the vector A, you know, A is bold, so it's not a scalar, it's a vector. Okay, only there is a special vector, a special notation for position vector. So it means the A is a position vector, only that we are using a special notation. So A in actual fact is what? In terms of it is OA. In terms of its normal, okay, what do you call it, form or notation. And okay, B is equal to this. Okay, however, we know, find the following. So we are supposed to find the following. So as usual, when you read question, check if you have salient part to underline. No. So after that, what do? You write solution. That's the first thing that you write. Okay. Then what do? You check if the questions are numbered. You have a major number question or a major question number. What do you do? Okay, you come and write, but here we don't have. Okay, so we will need to extract the information here. We will need it to find all that we need to. So after writing your solution and numbering, okay, where your questions are numbered, what do? You extract. So you write given or you can ignore the given, but okay, whatever information that you will need to do this must be extracted. And that's what I've done here. And when you are extracting the special notation vectors, please, you know that in writing, you are supposed to bring out the vector nature by using the tilde. Failure to do that will be costly, so take notes. So B tilde is equal to what you have there. So now you come to A. A, what are we asked to find? Therefore, we are asked to find the, so I will write, you can see that the questions are numbered, so we want you to number. And when you are moving, when this is the second line that I have used, okay, don't leave any space. The A here is not, you are not moving from a sub question to another sub question. That's your first sub question. So you come and write therefore. And the reason why I wrote therefore is that I am mature. I know that whatever that I write here, I won't change it. So it will still be equal to, and nothing will interfere. Okay, nothing will interfere in the sense that this is what I will always say that is equal to whatever that I will be doing going forward. So therefore, the vector AB, so in this case, I can put therefore here because I won't change. If you change, then you don't have to put your therefore here. Take note. Okay, so the AB vector plus BC vector will be equal to, what is your AB vector? And that is this 2, negative 1. plus your BC vector, vector BC is negative 3, 7. So you just substitute the corresponding vectors. Okay, don't forget your equal to, that's your first step. Your next equal to, your next step equal to. Okay, but take note, somebody can come and write equal to, only that I've advised, okay, that push your work here. So you can see that because I pushed it here, I have enough room here. If I need rough work, I can do it here. Or if it doesn't go there, I can even rule a line here and continue. So take notes. All right. Okay, so equal to your next step. Okay, so what do we do at this point? We are going to add corresponding components. So it will be 2 plus minus 3. Okay, then minus 1. Okay, plus 7. Okay, however, when you mature, this step will not be necessary. Okay, so you just combine what you have there mentally and you will do just fine. Okay, so at this point, if I add this, I will get negative 1. Let me take the laser just so that you can see pointer. Okay, so if you add this negative 1, add this, you get. And please take note, you don't go and write minus 1 over 6. Okay, you know, this has no over. This is representing one component, and this is representing another component, and they should be separated. Okay, they shouldn't be linked with what? With, okay, the division bar. Take note, because some students do that. Okay, so B. Okay, we are done with what? A. So when you are moving from A to B, you leave at least a line, maximum 2 lines. But like I always say, 1 line will be okay. So B, what are we looking for? We are looking for the vector BC plus the vector AB. So when you write your BC, don't forget to indicate your arrow. AB, don't forget to indicate your arrow. Other than that, what you have there will cease to be a vector. And that will be equal to just come and substitute. So at this point, you know you will have to add corresponding components. Okay, so but you do the addition mentally, which you can. So minus 3 plus 2, give you minus 4. My 7 plus minus 1 will be 7 minus 1, which is 6. So you can see that in this one, I skipped this. So this was only for explanation purposes. When you are presenting your solution, you don't need step. It will just waste your time and space. So as now that we are matured, we'll do it, okay, mentally. Okay, so that will be it for B. Now let's look at the C. The C we are looking at, okay, so even if you can compare the A, B, and the what? Sorry, the A and the B, you realize that vector AB plus vector BC is equal to vector BC plus vector AB. So if you observe that and study it carefully, this is telling you that vector addition is what? Is commutative. Okay, now let's come to this. Vector AB minus vector BC subtraction. So this one, I dealt with it, but normally, like I advise, this, okay, is supposed to come down so that you create more room here. However, if you come and write it equal to here, the next one, if you are moving from one line to the next line, you start writing close to the margin. So ordinarily, we will come and write equal to here, but I am advising you to stop doing that. Instead of writing the equal to here, push it to the side. Equal to, you always write close to the margin, equal to, then what do? It will be 2 minus 3, which will be 2 plus 3. That will give us 5. Remember, I've told you do it mentally if you can. Then minus 1 minus 7, that will give us minus 8. Okay, you try that of what? Of the BC minus the vector AB. Vector BC, you try that one on your own, okay, and you realize that vector addition will not be, okay, commutative. So the result that you get will not be the same as this. Now let's pick, okay, the E and deal with the special notation. So in this case, I'll also come and write therefore the vector A, and I'll write my A tilde, just so you can see, without the tilde you are doing, plus B tilde, and that will be equal to, what is your A? The A tilde vector A came in the column form, substitute. Vector B came in the column form, substitute. It means the nature of the vectors that you have there, anytime you are performing the algebra, will tell you, okay, the nature of the result that you are supposed to get. So if your vector is given in the column form, okay, it means your final answer of any vector that you are supposed to look for or find must also be in that same form column. If it came in the magnitude bearing, your final answer must be in that form. The Cartesian for the relative math, your final answer must be in that form. So take note. Don't change it unless otherwise stated. So at this point, what do we have? We are going to do minus 2 plus minus 3, which will give you minus 5. 4 plus 5, which will give us 9. We are done. Okay, so that will be it for the algebra questions, okay, that we have here. Addition and subtraction of what? Of vectors. And we dealt with, okay, two, I think, yes, we did more than two of the, what do you call it? Uh, Free vectors, okay, and position vectors. These two vectors are free vectors, these two are position vectors, and you can see that we use a special notation. So you know how to deal with, okay, each of these, okay, what do you call it? Vectors. Now, let's look at our next concept, and that is multiplication of a vector by a scalar. And like I said, when you know how to, it's the same idea in terms of points that we are going to extend to this. They have the same behavior, only that it's just the entries, okay, that the names will change. Okay, from coordinates to what? To components. Most of the things that you do in points or coordinate geometry is applicable here. Okay, so now what do we do? If k is a scalar and the vector AB is equal to, so here I'm dealing with only one vector. Okay, so with the component x, what, y. Then the scalar k times the vector AB will be equal to, okay, to be k times what? So at the normal circumstance, that's how it's supposed to be. Let me pick, okay, before you come to that. So it's supposed to be k, okay, times your vector x what with the component xy, which you know, just like point, you know, point, applying the scalar factor. Okay, what do? You multiply each of the coordinates by the scalar. So this will give you your kx, okay, ky. So your result, okay, the s component here now we are dealing with vectors. So s component will be kx, and what your y component will be ky. Your k here will be a value anyway. So take note. So that is to multiply a vector by a scalar, we multiply each component of the vector by the scalar. As simple as that, simplicity. Okay, so a vector, note, a vector can be multiplied by a scalar to make it shorter or longer or reverse the direction. So if your scalar, okay, is a whole number, a positive whole number, okay, indirectly is going to make your, what do you call it, your vector longer. Take note, if your scalar is a fraction, it's going to make your your vector shorter. Okay, if your scalar is negative, okay, it's going to change the direction. Okay, so take note, that's just extra information that, okay, you've been provided. Okay, with now, let's go and look at, okay, the following worked examples. All right, so worked example one. Given the vector AB, okay, with the component 2, -6, the vector PQ, okay, with the component -3, 7, your vector A, okay, the special notation, small a, is equal to, okay, -2, 4, with the component -2, 4, and the Q with its components here. Find, okay, the following. Okay, so you can see on your screens. So now let's go and look at the solution. Having read the question and we realized that there was nothing salient for us to underline, what do? We come and write solution. There is a major question number, so I come and write the major question number. Where I have this information, the major question number is what is beside that. So it means when I'm extracting that information, it should be beside what I have here. So you write given, or I've said you can choose not to write given and extract all that you have there. So I extracted these four vectors, two of them being free and the last two being what? Position vectors by the special notation. Take note. Okay, so now we come to A. Oops, forgive me. Okay, I think we can manage. Okay, so A, let me write it well. Oops, okay, I think let me clear it. I want it to look okay. I think this is better. We can manage with this one. It's better than the first one. So A, what are we supposed to find? The vector, okay, 2 times AB. So the scalar is 2. And then with this one, 2, I can work with it per experience. I know I'm finding 2 twice the vector AB. Okay, so I won't change. So it will be equal to 2 times my vector AB. And what's my vector AB? My vector AB is 2, -6. Okay, so I know my next step equal to, okay, you can see that I'm writing close to the margin always. So you know a scalar multiplying a vector, we multiply each component by the scalar. So it will be 2 times 2, okay, which will give us 4. You write it, you do that mentally. 2 times -6, which will give us -12. Okay, and that will be it. We've already drawn our conclusion. If therefore it's not there, then you are supposed to come and draw your conclusion. Take note. But we are mature. So we are bringing in or introducing, okay, maturity in our presentation. I guess my point is well made. Okay, so let's do, okay, the B as well. So B, okay, what are we dealing with? Therefore, -3, the vector PQ. Don't forget your arrow. Other than that, you are not dealing with a vector. And that will be equal to -3. You come and substitute your vector PQ. What's your vector PQ? -3. Okay, 7. Okay, so we know the definition of a scalar -3 multiplying a vector. We use, okay, the condition is that, or the rule is that we multiply each component by the scalar. So it will be -3 times -3, and that will give us what? +9. And -3 times 7 will give us minus, okay, 21. Okay, so this then becomes what? Our, please go and don't go and reduce, I beg. Okay, the S component here is explicit, the Y component is equally explicit. Okay, you don't reduce, we are not dealing with a fraction. Okay, all right, so take note, it's not 9 over -21 that you can take off reduction. Okay, so on that note, I will leave this one for you to try. Let's do one more, which will involve, okay, the position vector. Okay, so I'm not going, let's do one of the fractions so that at least you have a fair idea of how to deal with that. We come and deal with this. Okay, so this time around, C, what do we have? Okay, a scalar, so therefore your scalar half, okay, times the vector AB. Okay, our scalar is not that pretty, it's a fraction, but we are not worried. Okay, irrespective of the nature of the, we know the rule, so we can make use of it. So this will be equal to, okay, half times your vector AB. And what is your vector AB? Your vector AB, 6, or is it 6, 2, -6, forgive me. Okay, 2, -6, that will be your vector. Okay, quickly, so 2, next 6. Okay, so you know this is the same as, okay, half times 2, which is the same as 2 over 2. Okay, then half times -6. You can do it mentally, you do it mentally. Okay, so that is going to give us, okay, oops, my bracket is looking very ugly. Let me write it well. Oops, okay, so let's go for a better open bracket. So we have this, so it will be half times 2, okay, which will give us 1. Okay, indirectly the same as -6 over 2, which will give us -3. Or half times what? Okay, you know, if you want to use your calculator, you can use your calculator. Okay, and you will get the same. But this one you don't need. Okay, don't waste your time on your calculator. You can do it mentally, unless you are not sure of yourself, or you want to use your calculator to be very sure. Okay, so that will be it for, okay, the C. So you know how to multiply a scalar which is positive, okay, by a vector, or a vector by a negative, okay, scalar, a vector by a fraction scalar. Okay, so now what do we do? So we've done negative whole number, positive whole number, and a fraction. Okay, this one is a positive fraction, this one is a negative fraction. So you can try that one. Okay, and send me your comments, your results, as well as your comments. Okay, so now let's look at E. Okay, so E, what are we looking for? Therefore, we are asked to find, so 5 over what? Over 2A. That's what we are asked to find. So don't forget your third, are very critical. When you write your A, that is what will make it a vector, because in writing, that's how we indicate vectors, okay, in the special notation form. So that will give you 5 over 2 times your vector A, which came in the column form, and that is -2, okay, 4. Okay, so with this one, if you can't do it mentally, you know. So this is going to give you 5 over 2 times minus 2. So the 2 will cancel. So you are going to get minus what? 5. Okay, so that will give us minus 5 for the S component. However, the Y component, if you like, that's why I say create room here for your rough work. So that will give you 5 over 2, okay, times what? 4. So you know that this will go here too. Okay, so it will be 5 times 2, so that will give you what? 10. Okay. Okay, I could have done that mentally without doing the rough work. However, if this happened to be a rough work, don't forget to strike it out, but do it in such a way that will still be readable. Okay, so on this note, that will be it for this particular what question. Now let's go and look at our second question, still on what on algebra of what of vectors. Okay, so this time around, you can see that, okay, the questions involve multiplying a scalar, okay, a vector by a scalar, and also adding what, two, okay, or more vectors. Okay, so if you are able to do this, any question at all, you should be able. So this question will need us or will require us to make use of all that we've learned so far. Okay, so as usual, okay, what do you do when you read a question, check if there is any salient part? No. Okay, the first thing that you write is solution. Questions are numbered because your solution must be numbered. So I'm looking at solution to major question number 2. Okay, so question, I can extract this information there. Okay, so given, or I can choose not to write a given, but this must be extracted. I've been given 3 vectors, all of them are, okay, position vectors, special vectors. Position vectors given in their special notation form. Okay, so now what are we going to do? So we come to A, having extracted what you would need. When you are coming to write your A, you know, okay, you don't leave a line. You are not moving from a sub question to another sub question. It's from A to B, B to C that you leave, okay, lines. Okay, so with this one, okay, I wouldn't take anything out. So I will conclude with what I have there. So I will just write there for 3A and okay plus B, okay, will be equal to 3. Okay, what is my vector A? Is in the column form 6, 2. Okay, plus B. What is my vector B? Okay, negative 4. Okay, 12. Okay, please, at this point, okay, if you present your solution this way, you are doomed. Okay, in your voice, you should know why you are doomed. Okay, what you've stated here is not a vector, it's a scalar. Okay, the A here, this is a scalar, this is a scalar, this is also a scalar. So you can't see vector, any vector here. So you are not dealing with vectors. Take note, okay, for this to be a vector in writing, you should bring that tilde. This to be a vector in writing, you don't forget your tilde. Take note if you cherish marks. Other than that, it will be B0, M0, A0. Take note. So at this point, my simple advice is whenever you have this situation, okay, always deal with the, what do you call it? Deal with the product first, the scalar and the vector first before you come and, okay, add. So that's what we are going to do, okay, as well. Okay, so what do we do now? Now we are going to multiply the 3 and the 6. Okay, we know how to multiply a scalar and a vector. We are experts now. So this will give us 18. 3 times 2 will give us 6. Okay, then plus your this vector, which is the negative 4. Okay, 12. So at this point, you know, you've gone back to how to add 2 vectors. So it will be 18 plus minus 4. Remember, we add corresponding component. So it will be 18 minus 4, which will give us what? 14. Okay, then it will be 6 plus 12, which will give us what? 18. We are done. Okay, so I've told you add mentally, okay, or combine your components what mentally. Even when we were multiplying, we did that mentally. How much more addition or even subtraction? So take note. So that will be it for the A. So maybe let's do the B together. I guess you are following. Okay, so now let's move on. B. Okay, B. Okay, therefore that one too, I can work with it straight away. Okay, whatever I'm finding, I'll substitute, simplify, and I'll get whatever that I'm finding. Okay, so let me clear this. Okay. All right, quickly, let's continue. So we are looking at, so don't forget 3 vector A, so A tilde minus 2B tilde, don't forget. Okay, so this will be equal to 3, okay, times your A. A again, we know the vector A is 6, 2. Let me write it well, okay. Then minus 2, your vector B is what? Is minus 4, okay, 12. Okay, so let me write my 2 well. Okay, so it's now clear. So now this 2 is also not looking pretty. Okay, so this will be equal to, I told you come and multiply the scalars, okay, and the vector, then later you add or combine. So 3 times again, so this will give us, okay, we've done that one, so we can infer, or you could have inferred, okay, from here because it's the same question. Okay, but I'm using that to explain, but you know how to show maturity in your presentation. By now you should know. So this will give us 18. Okay, so 18, okay, 6. That is what we have there. Then minus, if you keep the minus, then you are going to multiply, take your scalar as only 2. However, if you use your scalar, take your scalar to be minus 2, then you have to put plus here. Take note. I'm going to repeat. Okay, here I'm going to keep the minus. So once I keep the minus, then it means I am, okay, shielding, okay, the 2 from the negative. The negative is no longer affecting the 2. So I'm going to multiply these 2 to be positive by all that I have here. So that will give me, okay, 2 times negative 4. Remember, I've kept the subtraction sign here. So it will be 2 times negative 4, which will give us negative 8. 2 times 12, which will give us 24. Take note of that. But I said the same way somebody, okay, can do this. Okay, write the 18, 6. Okay, then take the scalar to be negative 2. On that note, then you have to write plus here before you come and multiply, okay, this each of the components here by negative. So that will give us, okay, 8, okay, then minus 24. Okay, so we'll do it here. We'll come and see if you get the same result. So at this point, your next step, okay, you combine mentally. So that's going to give us 18 minus 18. So it will be 18 plus what? Plus 8. Okay, minus will give us plus. So that will give us 18 plus 8. And we are going to get what? 26. You agree? Okay, then you get 6 minus 24. Okay, 6 minus 24 will give us minus 18. Do you agree? Okay, so that will be our final result. Let's come and do same here. So 18 plus 8 will give us 24. Did I say 24? 26, forgive me. Then 6 plus minus 24, which will be 6 minus 24, will give us minus 18. So irrespective of which direction you go, you end up getting the same result. Take note. But our advice, keep the negative, then push towards the positive inside. Then now you come and subtract. So going forward, that's what you will do. So if I vary it, it's just for you to know how to deal with it in each situation so that you perfect your skills. Okay, so at this point, okay, I think, okay, so let's do one more. Let's look at what the D. Okay, then that will guide you to do the E. I think E will be given to you as an assignment. So let's look at the D. D, so we'll skip the C. You will try that one on your own. Take note. Okay. All right. So at this point, what do? We are going to write therefore because, okay, we will, okay, so therefore we'll conclude with whatever that we are going to write. So therefore half A tilde, okay, don't forget, plus 2B tilde minus C tilde. Okay, so this will be equal, this time around you are working on 3 vectors. So it's the extension of whatever that we learned here. Okay, so what do? It will be half your A. What is your A? A is in the column form, and that is our 6, 2. Okay, plus 2B. The vector B tilde, B is what? Our negative 4, 12. Remember, when you are substituting, you have to be very careful. Immediately you change one of them, you are doomed. Okay, then minus your C. So the C is what? 5, okay, -1. So immediately any of the components of the vectors that you are or you substituted there is wrong, we are doomed. So be very careful. So now this will be equal to, okay, so this is going to give us, okay, half times 6, and that will give us 3. So it's the same as 6 over 2. So 3. Then half times 2 is the same as what? 2 over 2. So that will give us 1. Remember, let's work on each vector in the scalar first before we come and combine. So this will give us plus the sign there. I will keep the sign, then I'll come and multiply the senders. So that will give me 2 times -4, that is -8. 2 times 12, that will give me 24. Okay, then minus here, the scalar here, so it's 1. So you keep exactly what you have here. Okay, -1. So at this point, we are going to combine. So just as we could combine, okay, two components mentally, you should be able to combine, okay, more than two mentally. Because if I ask you to add 2 plus 3 plus 4 plus negative, you should be able to do that. Okay, so that's what we are going to do. So it will be 3 plus negative because we are adding corresponding or combining corresponding component. So it will be 3 plus -8, which will give us what? -5, then -5. So that will give us -10. Okay, then this will give us 1 plus 24. That will give us what? 25. Then minus 1. So it will be plus 1. So that will give us 26. Okay, so this will be 8 4. Already you should know that we've drawn our conclusion. Take notes. So because this is our conclusion. Therefore, you see, otherwise, if you didn't write a therefore, then when you were going to combine to get your final answer, you come and write a therefore there, then write this again, then you write equal to, which you know, okay, will be, okay, waste of time. So just put your therefore here because whatever you have here is taking the equal to, nothing interfered. Okay, all right, so this will be it for question in words 2. So we are done with the algebra of what? Of vectors. So we now know how to add and subtract vectors, how to multiply a scalar and a vector. Okay, or multiply a vector by a scalar. Okay, so now let's look at the last concept, okay, probably, okay, for the day. All right, so we are going to look at the magnitude of a vector. You know, vectors deal, okay, with what? Points. So you move from one point to another. So just as points, okay, if you are looking at a line, we can find its magnitude. A vector too, we can find its magnitude. That's why we said, okay, both lines and vectors, they have what? Magnitude. The distinction is in the direction. Okay, one has, which is the vector, but okay, scalars they don't have. Let me put it that way, which is a line, not a vector. So in this case, let me read. The magnitude of a vector is the length of a vector. It is also known as the modulus and is the absolute value of the vector. So it's also known as the modulus or the distance, but usually we use magnitude. Okay, so take note. So the magnitude of the vector, the length of the vector, but we usually use magnitude. Okay, that is if I have the vector AB, which is equal to my usual x and y component, then the magnitude of the vector AB, so the vector in the column form, is denoted by, and you know, just as if you have the line AB, the magnitude of the line AB will be AB in a cell, okay, in the absolute value. But here is a vector, so you put the vector in the absolute value. And it's defined as, so this is how, okay, the formula for finding the, what do you call it, the magnitude of a vector. And you know, okay, when we did the coordinate geometry, you realize that the magnitude of, okay, of a line from one point to another point, okay, we use the Pythagoras theorem, okay, to determine, okay, that. So here, the duty or the point is know this formula. Okay, the magnitude of a vector will be root of the x component squared plus the y component squared. As simple as that. But when we are dealing with what do you call it, a line, we said the magnitude will be the change in x, okay, squared, okay, plus what? The change in y, okay, squared. The one that gave us x2 minus x1, s sub 1 minus s sub 2, okay, all squared. Okay, then the plus y sub 2 minus y sub, or yes, I think it was s sub 2 minus s sub 1. It doesn't really matter. I told you, okay, because of the square, then minus y sub 1, okay, all squared. So usually it will be the terminal, okay, x minus the initial, what have you. Okay, so this is it. It's just basically the s component, you square it, the y component, you square it, then you take the square root of, okay, the sum, as simple as. So it's the square root of the square of what, the s component plus the square of the y component, as simple as that. So quickly, let's go. I won't bore you with the proof. We could have, okay, done that, but it's just to, your business here is to know the formula and know how to apply it. Okay, possibly once you are in the house, you can verify, okay, or find, okay, how we can prove that. But I won't bore you with the proof here. So let's move on to this particular question. It's fully loaded, okay, a lot, but don't worry, I'm not going to do all as usual. I will do some to, okay, with you, and the rest will be given to you. Some to try, not to submit, others, okay, to try, then you submit your answer for me to go through. So when you read question, okay, so we are going to read the question, check if there is any salient part to underline. Okay, so given that the vector AB is equal to, okay, so the vector PQ is equal to, so then your special, these two special notation, position vectors. So three vectors first to next to. So they are, you know, they are corresponding components. Okay, just as you can see on your screens. Now, what do? We go to AI. So solution, we come in given, or you can choose not to write the given, but you have to extract all the four vectors. Two of them being free vectors, and the last two, that are the first two free vectors, last two, okay, position vectors. Special notation used there. So we come to A. Okay, but it's not AI. Okay, AI, what are we supposed to find? We are supposed to find the magnitude of the vector AB. Okay, so the magnitude, so here I always want you to think before, okay, you write exactly what you have there. So before you write, so the magnitude of vector AB, I know. Okay, so I can find its magnitude straight away. Because so on that note, I can write the therefore straight away and come and write the magnitude of the vector AB. Don't forget your arrow. And that will be equal to, okay, at the normal circumstance, what I'm going to write here is not necessary. Okay, okay, but I'm using that to explain. So it means it will be your vector AB. What is your vector AB? 3, 4. Okay, in the absolute value, but I've told you this is not necessary. So going forward, I won't write it. Okay, which will be equal to, what do we do? Anytime you are finding the magnitude of a vector, it will be root of your s component squared. So it will be 3 squared, which is my s component. Then plus the y component, which is 4, okay, squared. Okay, so this will give us root of, okay, you can see that I'm dealing with this same question. I'm not moving from a step to another step. So under no situation should I leave any line not attended to. Okay, so now this will give me 3 squared, which we all know is 9, plus 4 squared, which you all know is 16. Okay, and this will give us 9 plus 16 will give us root of 25. So that gives us what? 5. But don't forget, you know you are dealing with what? Magnitude is length. Okay, distance, and you should always have a unit. But because we don't know the exact unit, you attach, okay, units. Okay, as simple as that. I guess my point is well made. Okay, I told you this is just for explanation purposes. Okay, so going forward, okay, I won't do this again. So let's move on to, okay, the PQ, II. So I'm looking at AII. Okay, that one too. Do I know PQ? Yes, I know PQ, so I can draw my conclusion. I can, once I know the exact vector that I'm finding its, okay, magnitude, I can draw my conclusion. Therefore, the magnitude of the vector PQ will be equal to, I know PQ, so it will be root of, I know the S component, which is 4, so it will be 4 squared. Okay, then, okay, plus the Y component, negative 3, so negative 3, okay, squared. Okay, so this will be, so here my advice is anytime you are substituting the x component and the y component, okay, put it in brackets before you bring your square. Okay, because in a situation where it is negative, if you don't bring the bracket, you are doomed. So play it safe. Always put it in bracket, whether the bracket will be necessary or not. In this situation, okay, we can ignore the bracket. It will not be costly. Actual the bracket will not be necessary, but play it safe. Always put it in bracket. So that will give us root of 4 squared, we know is 16, minus 3 squared. If you ignore the bracket, then the answer would have given us negative. This one means minus 3 times minus 3, and that will give us what? Plus 9. Okay, so we are going to get again root of what? 25. So which will give us what? 5, okay, units. Okay, don't forget your units. Okay, so that will be it for I, that is AII. Now let's do, okay, one with the scale factor. Okay, so let's do this. Then after that, we'll come and handle maybe one that we need to sum. Then we come to the special notation one. Okay, so let's see. Okay, I'm going to go for Ivan. Okay, you can try the, or let me do the 3. Okay, so that's so that you try the one with the negative. Okay, so let's do the I. Okay, I. You can see that I'm doing the easy. Okay, one. Okay, no, I'm rather doing the difficult one. Okay, so again, let me see. I'm looking at 3AB, 3 times the vector AB. Do I know 3AB here directly? No, I don't know. There's 3AB, so it means I have to perform a little bit of what? Algebra on my vector that I'm finding its magnitude before I can find its magnitude. Please listen carefully. So, like I always tell you, think before you write. So, at this point, what do? You cannot. So, if you come and write, assuming maybe you wrote 3 magnitude of what? Vector 3AB. Okay, you realize that no, I cannot, okay, what do you call it? Should I say yes? I don't know the vector 3 times AB directly. So I have to go and find it before I can find its magnitude. Otherwise, this is okay, a way to go. But I will advise you to deal with it in another way. So let's deal with it. So this will give us absolute value, and you need to work on this. Without the absolute value, if you don't bring the absolute value, you will know that you are wrong. And very soon I will throw a little more light on that. Okay, so this will give you 3 times your vector AB. And what's your, oops, okay, your vector AB, forgive me. Okay, your vector AB is what? Is 3, 4. Or we've done 3, or no, you haven't done it. Okay, 4 in this question. Then you bring your absolute value. Without the absolute value, remember the magnitude of a vector is a scalar. So if you don't indicate the absolute value here, and you just write equal to without the absolute value, write 3 times this, you are wrong, because this will give us a scalar. However, what you are saying is equal to will give us a vector. So you cannot ignore the absolute value and later go and use that. No. At the point that you are simplifying and you still kept your equal to, you have to still indicate your absolute value. The absolute value can only go when you are applying the formula for finding the magnitude. But here we are not applying. The next step, are we going to apply the formula? No, we are working on what we have there. So the absolute value should still be there. So that will give us what? In brackets, okay, your s component when you multiply will give us 9. Okay, then you get what? 12. Okay, then this will give us what we have here. I hope you are following. Okay, so on this note, at this point, we know the exact vector. So we can apply the formula. When you are applying the formula, the absolute value goes. So you get your 9 squared, put it in bracket, don't forget. Okay, then plus your 12 squared, also in bracket, 12 in bracket squared. Okay, so which will be equal to, now 9 squared we know will give us 81. Okay, plus 12 squared we know will give us 144. Okay, I hope, okay, I'm right. So at this point, okay, assuming this is my next page, so I'm ruling the line. So because I moved my presentation here, So you can see that I have this room, okay, to continue. So I'm ruling my line. Okay, but you cannot rule your line with your free hand. Use a straight edge. So that will give us, I think I can write it here, root of what? If you add this, we are going to get, is it not 225? Yes. So that will give us root of 225. Okay, so root of 225, okay, 225 is a perfect square, and that's the square of 15. So that will give us 15, okay, then units. Don't forget, so we are done. Okay, so that will be it for the VI. Okay, VI. So you will try, no, it's I, rider. Okay, I. Then I said you will try the IV. Now let's go and look at the V. Okay, together. Let me see whether I have an S. Okay, so we'll do the V rather here. Okay, so V, what do we have? So we are looking at still AV. So AV. Okay. So no, I think I said the other one. Forgive me. I just remember I said I will teach you the right way, okay, to go, the ideal presentation. So in this case, alternatively, alt, okay, what are we giving? We are dealing with, so your question number again will come, I. Okay, then I said think before you write. So when I look at the vector that I'm going to find its magnitude, I don't know that vector. So I need to find that vector before. So I will come and write, okay, I will take only that vector out. So I will come and write 3, or even if you come and write, okay, the magnitude of 3AB, vector 3AB. Okay, that is the 3 times vector AB. Okay, if you write this, which I said, if you thought before writing, you wouldn't write this anyway. Okay, so yes, I can find this. I don't know this vector straight away to find its magnitude. So to use the formula straight away, it means I need to go and find this. So I'll come and take whatever that I want to write and find, or I need to work on. So I'll write but 3, vector 3AB. Okay, did I say vector 3AB? 3 times the vector AB, forgive me, will be equal to, okay, 3 times the vector AB. And what's the vector AB? 3, 4. Okay, so then that will be equal to, okay, 9, 12. Okay, so at this point, I know the exact vector. Okay, this vector that I'm finding its magnitude. So I can come and write therefore. With this one, okay, we can write it therefore here as well. Okay, because you can see that the same thing, the vector, magnitude, magnitude, magnitude. Okay, move on. So in this point, something has interfered. So I come and write my therefore. The magnitude of the vector, so 3 times the vector AB, okay, will be equal to, I know the formula, is root of, okay, my 9 squared, okay, plus what, 12 squared. Okay, and the continuation equal to your next equal to, remember, your next line, so you write it close to the margin. So the continuation will be from here going the same. Okay, so which will give us root of 81, which is the 9 squared, plus 144, which is the 12 squared, which will give us root of what, 225, okay, which will give us what, 15, okay, units. Okay, take note of that. So it's the same thing. So whichever way you want to adapt, you adapt. Only that this one comes with a risk. Okay, in that if you fail to indicate your, whilst you are working on this, you'll still be writing the absolute value, which, okay, somehow will take your time. So take it, simplify it to, okay, the form that you want it to be, okay, the actual vector, then now you come and take that one and find the magnitude. So even at this point, okay, if you write or you have equal to 9, the vector 9, 12, okay, if you don't write this here and you come and write equal to and apply the formula, obviously you know this is a vector. What you are doing here will end up giving you a scale. I'm saying that assuming maybe you wrote equal to 9, 12. Please listen. And you came to write equal to, then you apply the formula. No. at this point, okay, you've lost, okay, your way. This is a vector. Okay, however, if you are finding the magnitude, to give you a scalar. So here you have to write something before it's equal to. Okay, and unless what you had up there was absolute value. In that case, what was up on top of this, we should also take the absolute value. What have you? I guess my point is well made. If you don't get it, okay, pass your comments, or in our next lesson, bring it out. I will explain further. Okay, so that will be it for the. Okay, so we're looking at the vein. We are about looking at the vein. So with the vein two, okay, let me see. This time I'm going to deal with it maturely. I need to find the absolute value, which is the magnitude of the vector AB plus the vector PQ. Do I know the vector AB plus PQ given directly straight away? No, unless I add this vector and this vector. That will give me my vector that I'm supposed to find its magnitude. So on that note, I won't write this, okay, or come and write therefore. Or, okay, I will just pick, I need to work on this. I'll come and write, okay, vector AB, okay, plus vector PQ. Okay, that's what I have, vector AB plus vector PQ. If you like, you can bring the absolute value before I come and write your plot. But I will write is equal to, I know I need to work on that. So you can write but also here. Okay, then that will be equal to, what is your AB? You can see that usually I will not write the equal to here, but those of you who do that, I want you to tell you that, or I want to tell you that the next step come close to that. That's why I'm going your route. So, okay, then plus, let me, okay, indicate mine, then come and put the columns there. So AB is what, 3, 4. Okay, then PQ, vector PQ is what? Is 4, okay, negative 3. Okay, so in effect, you can see that I'm coming down. So the next thing that you usually you write equal to here, come and write your equal to here. Push your work to the side. You know that for me, I would have written the first equal to down here. Okay. Okay, so now we add mentally. So 3 plus 4 will give us 7. Okay, 4 minus 3 will give us what? 1. Okay, so now at this point, you know the vector. So you can go and find its magnitude. So I'll write therefore the magnitude of the vector AB plus the vector PQ. Okay, will be equal to, I know the rule, the formula, x squared. So x is 7. Okay, squared plus y squared, y is 1. Okay, squared. Extend this to cover that. And again, you can see that I'm coming to my next line. So I write equal to close to the margin. It's not necessary for your equal to be in line. Push it so that you create room for your rough work or even continuation of your main work. So that will give us root of 7 squared is what? 49. Okay, plus what? 1. So we are going to get root of what? 50. That is what you have. So at this point, okay, you feed your calculator with this. Okay, root of 50. If your calculator gives you or throws back the root of 50 at you, then it means this cannot be reduced. Otherwise, your calculator will give you the reduced version because this will give us 25 times 2, which is the same as 5 roots of 2. Okay, but don't forget your unit. Okay, take note. Your calculator will give you your answer in the said in its basic form. We reduce the said. Please, once again, avoid writing the decimal of this unless the question asks you to. Okay, approximate, don't approximate. So this is the exact magnitude. Okay, take note. So that will be it for the, what do you call it? The A questions, the one that we are going to do together. So we are now going to the B questions. So B again, I'm moving from a sub question to another sub question. So I will leave a line there. So B, then I come to I. Okay, so BI, what am I supposed to find? I need to find the magnitude of this vector A. Do I know A? Yes, so I can find its magnitude. So I can write it therefore, then come and write my A without a tilde, be careful. So A tilde, you are writing it. If you like, you can come and write equal to here and come down. And that will be equal. The magnitude of A will be equal to what? What are we looking for? So it will be, we know the vector, so it will be root of, you know your S component, Y component. So that is minus 8 squared. Then plus, okay, 6 squared. I hope you are following my professors. Okay, so on this note, you come down, next line, close to the margin. You write here, you don't come and write equal to here. So what do we do? Root of, okay, a squared will give us 64, okay, plus 36. Okay, I guess we are going to get a pretty value. I can see that. So root of what? 100. Okay, which will give us, okay, 10. Okay, but 10 what? Units. As simple as that. I guess my point is well made. So that will be it for that one. So it's basically the same thing that we are going, only that here the vectors came in the special notation form. So when you are writing it, you have to be very careful. Very careful in the sense that you don't forget your tilde or tildes. Okay, don't forget to indicate your tildes. Okay, below your A and the B. So I'm going to equally skip this and maybe come to V. So V. Okay, what do we have? Okay, so we are going to have, okay, so let's see, do I have A plus B vector? No, I don't have. So I will work on it. So I can come and write, okay, but, okay, the vector A plus B, or you can choose not to write the but, will be equal to, okay, what do we have? We have, what is my A? A is the vector, so plus my B vector. I'll come and indicate the corresponding component. So A is what? A tilde plus B tilde minus 8. Okay, then 6. B tilde is minus 5. Okay, minus 2. Okay, so I'm coming down, so close to the margin equal to. It's an expression. So the equal to, usually you write it here, and I'll continue to repeat so that, okay, you take note of that. I'm emphasizing. So minus 8, I will do it up to a point and guide you. In any case, whatever I wanted to say, I've said it. Okay, almost. Okay, everything. So minus 8, okay, plus minus 5. So adding corresponding or combining corresponding components. So that will give us, okay, minus 13. Okay, then 6 minus 2 will give us positive what? 4. So at this point, okay, you know the exact vector, the vector A plus B in its simplified form. Okay, so what do we do? You come and write there for the magnitude of the vector. You know the vector. So you can find its magnitude will be equal to root of, okay, minus 13, okay, squared, okay, then plus 4 squared. Okay, so at this point, you are more than capable to continue. So you continue your answer, you don't forget to attach units. Okay, and if it comes in the said form, don't leave it in it's okay, not in its basic form. Always, so you cannot conclude here because when you were doing said, you were told that you cannot conclude with a said which is not in the basic form. So check whatever said that we get there. If you want to verify that it's in its basic form, feed your calculator and press equal to. If it's already in its basic form, your calculator will throw it back at you. Okay, if it is not, your calculator will give you the reduced version, then you write and you attach units. I guess my point is well made. Okay, so on this note, okay, that will be it. This will be your assignment. I will put it on the platform, okay, for you to try. Okay, so please, okay, once again, thank you very much for a very successful, okay, lesson. Please watch the video. Okay, you can like, share, okay, and comment. God bless us all.